So in today's session, I'm going to kind of go through all the items that I need to cover in case I needed to do a coding interview again. I realized the first time kind of going through this, it can always feel quite overwhelming, and that's because there's just so much that you don't know. The field is wide and such. I've come to find that there's a lot of value in having maybe a standard place to start, and then you have a broad overview of everything that is there. So, with that said, probably the first place that I would start by looking at is data structures. So these are typically, without a good understanding of them, it's hard to be able to talk about things like performance. So there are quite a number, and some of the more obvious ones would be something like arrays. So arrays are, for example, a linear data structure. It basically stores element in a contiguous block in memory. Really, why arrays are important is because you can access one directly using its index. So that's why you might want to use them. Other important structures here are things like linked lists. So these again are linear data structures, quite similar to arrays, but the only difference is that the nodes are tied together by references. This makes it fairly easy to store data in it, because you just need to link to the last item. However, finding something in it might also mean traversing the entire list. The other thing that you want to look at here is stacks. So again, another data structure, linear one. The only difference is that you can only remove something from the top, and this one you normally find them, for example, this is something like a stack trace or something like that. So that's because they're normally used for implementing things like recursion, function calls, and they usually used for managing temporary data. I imagine a situation where if I'm like doing a quick note, I'd take that note, and once the note is done, I'd more or less very quickly delete it. So there are other more advanced structures like queues, which is a bit different from a stack in the sense that a queue takes from the end rather than from the beginning. So while a stack you put on top and then you remove from the top, a queue you kind of put on the top but you take from the bottom. Is normally very useful when you want to do things like schedule tasks or manage waiting lists. You can imagine a scenario where you are in the supermarket and the last person to come in suddenly gets served. You'll be not happy about that scenario. So these kind of structures prevent items like that. So there are others as well. There are trees, graphs, hash table, heaps. I'll maybe cover a bit more about how data structures work in a later video. For now, I think you have to consider things like the algorithms that are there, which again are quite many. So there is the searching. There are algorithms that deal with things like search. This is going to be quite popular. I'm not always going to be searching for something, and here are examples like a linear search. Remember when you talked about an array where you go from one element to the next, just sequentially looking at items. That's one of the ways of getting it. So important concept here is the target element which you're trying to find, and then usually in any searching problem, sometimes there's a way to get to binary search, especially if the thing is already ordered, which takes me to the next part, which is the sorting. So whenever you're thinking about sorting, and just for clarity, I'm here, I don't know whether I should be taking some notes. Maybe just going to be searching and then sorting. I think I talked about like the linear algorithms, then I'd also talked about things like the queuing algorithms, but obviously there are quite a number there. So continuing on here, we'd have sorting. This is where things get a bit more interesting. You'd have things like bubble sort, you'd have insertion sort. These are the most basic ones. So bubble sort is where you basically compare adjacent element and sort them until they are in the right order. Insertion sort is also very similar, where you build a final sorted list one at a time. So these two are very expensive. You can also go a selection sort, where again you find the minimum element from the unsorted portion and swap it with the leftmost unsorted element. So in effect, you're creating two arrays in place. One is sorted, the other one unsorted, and you're continuously reducing the size of the unsorted one. It's called selection. Honestly, I'm not sure. And you have things like, like merge sort there, and quick sort, and so on and so forth. There are other more complex problem here, like dynamic programming. Now, it's basically what I'd probably call it better divide and conquer. So just take a problem, see if there's a way of expressing that problem in a more simple way, right? So maybe to try and maybe give maybe an example, or something of that sort. You want to ensure that you want to kind of wanted to ensure that you look at issues, or the sub problem that you have created is one that can actually be solved. So for example, some of the things that you can put in is something like, I think it's called the largest common subsequence problem. So the longest subsequence problem is basically a compliance problem that where we try to find the longest common subsequence that is common to two or more sequences. So an example here is if you have two sequences A and B, and sequence A is something like ABCDGH and B is AEDFHR, then LCS of A and B is ADH. So that's the longest subsequence. So the only way to solve that is actually to go ahead and use dynamic programming or divide and conquer. I mean, the others here, like edit distance problem, knapsack problem, and traveling salesman, I won't necessarily go through all of that. The idea is you just want to make sure you have identified the sub problem. You can solve the sub problem optimally, and you have to find a way of storing the solution. So that's one way of looking. That's kind of one way of looking at it. The other types of algorithms, which maybe I'll cover in more detail later. So we have greedy algorithms, recursions, backtracking. Of course, then we go to things like graphs. The graphs I'll even just take a note because they're so like interesting structures. You have like breadth first search, depth first search. There's something I think it's called Dijkstra's. I mean, I've never been able to pronounce it properly. Let me see if I can even pronounce it properly. I think it's Dijkstra. Yeah. So this is basically, I mean, this one I'll mention because it's so interesting. It's one that finds the shortest path from a single source vertex to all other vertices in a weighted graph. So as you can imagine, this is super useful for situation where, for example, you want to drive somewhere, and maybe you consider, oh yeah, I really have a preference for buses, or I really have a preference for trains, and you're able to weigh against that. Kind of quickly jump into programming concepts. I'll probably expand more on items in the algorithm a bit later. Anyway, for programming concepts, probably the biggest one you want to know is big O. I know that there's no interview where that will not show up. And really, I think even in real life, right? So this is one of the ways that you get to understand an efficiency of your program. So you're thinking about it from a time and space complexity. There's no other easy way that I know of going through that. Anyway, I think you also need to understand OOP. So this has stuck for a very long time. I know I have people who have been big supporters of functional, but as it stands right now, this is still like the biggest flex, and you're definitely gonna get that in an interview. Then you have to kind of understand recursion and iteration, and I think this kind of ties to all the problems you'd ordinarily kind of see. So in my opinion, really, I don't think recursion is more efficient. I know it does use some of the structures we talked about, like stacks. I think it just kind of hides that complexity in terms of the computation. However, it does make your code much easier to read. Can be a bit confusing. I think that's a good place to kind of be in. So there are other more advanced concepts like bit manipulation and memory management if you want to really go that deep. Another one is kind of like techniques. So kind of getting in, you want to see how to go about it. I am usually like a big advocate of first to go with brute force. See if that's a possibility. Then we can try some of the more dynamic programming items like divide and conquer. You can try two pointers. It's the kind of thing that make it like very very easy. I think someone once told me there are like 22 only such approaches. To be honest, I kind of need to build my knowledge on that as well. But I don't know of others like sliding windows, where you basically have one sliding window that moves from one window to the next, performing computation on each particular window, and so on and so forth. So that's how I look at it. And then is language of choice. Mine is Python, simply because it's just so easy to read. I've never seen this be a big blocker in most interview situations. It doesn't matter what language you know, as long as you can express your ideas in that. That language. Yeah, so that's kind of it, and this covers the universe of programming. Not all of it, but almost the quick walkthrough. I'll try to see if I can get into more details over the next few days. Bye bye.